Problem number 10. The following information applies to the next two problems. An experiment consists of pulling a heavy wooden block across a level surface with a spring force meter. The constant force for each try is recorded, as is the acceleration of the block. The data are shown below. Which is the best value for the mass of the block? So first of all, we can write here the equation for motion. This is our equation. Mass multiplied by acceleration equal force of the spring minus force of friction, which is mu mg. If we look at this equation and look at this representing data, we can see that force is a function of acceleration, and according to this equation it must be straight line. And we can draw a picture. From this picture we can see that mass could be defined as a slope of this graph. So delta F divided by delta A. And the best way to choose this delta is to take furthest points, like this one and this one, and this one and this one. So we can write this immediately. We choose points 5.05 minus 3.05 divided by 0.495 minus 0.95, 0.9. So this is our answer. We have mass equal 5 kilogram, which is a B answer. Problem number 11. We have the same setup as for previous problem, number 10, but the question is this. Which is the best value of the coefficient of friction between the block and the surface? Again, to solve this problem, we can use this equation, m equal F minus mu mg. And now we already counted what is the mass. It's 5 kilograms. So we can use all data which we already have, and this is our calculations. So here we use force 5.05 and acceleration 0.495. Put it in this formula, and finally we found that mu equal 0.05. That's answer A. Problem number 12. A uniform disk rotates at a fixed angular velocity on an axis through its center normal to the plane of the disk and has kinetic energy E. If the same disk rotates at the same angular velocity about an axis on the edge of the disk, still normal to the plane of the disk, what is its kinetic energy? So first here let's draw the picture. If our disk rotates around center, point O, we have a moment of inertia at this disk equal to I0, which is 1/2 mr square. This is formula for uniform disk. But from other hand, if this disk rotates around a point on some kind of distance d from the center of this disk, center of mass of this disk, we use a so-called parallel axis theorem, which states that moment of inertia equal to moment of inertia around center of mass plus md square, where d is distance between center of mass and the point of rotation. In our case, distance is equal exactly radius, and it means that we just triple moment of inertia. And last point, kinetic energy for rotation. The formula is, we see that kinetic energy proportional to moment of inertia. If we triple moment of inertia and leave the same angular velocity, we will triple our energy. It means that the answer is D, 3E.